Hello, Matrix. My name is Retief, and I'm a project manager with the South African Institute of Chartered Accountants. Normally at this time of year, we'd be seeing you at your schools, or you'd be with us at one of our Tutuga development camps. But because of the situation, we aren't able to do that currently. If you're feeling a bit frustrated and annoyed, we completely understand, because we're feeling the exact same way. And we understand how tough it must be without having the extra support to help you through. And whilst we can't be with you in person, we're trying our best to be with you in the only way we can right now, and that's digitally. To help you with your matric revision, the team and I have reached out to some of our favorite educators to create a series of videos in the most common problematic topics that matrics struggle with. We hope that these videos are able to assist you and help you feel less alone during this time. All the best for your matric exams, and good luck, matric class of 2021.
Welcome back. We're going to continue with the examples given. So we got f of x, which is x minus 4 squared minus 9, which is the parabola in the turning point formula. So the first question there is calculate the coordinates of E. Now obviously E is the turning point. So if you have a look at the graph there, E is where the graph is turning. So if you look at the question, minus 4 means the graph is moving 4 units to the right, and that means the graph is moving 9 units down. So therefore the turning point is 4 and negative 9. So let me write it down there as well, 4 and negative 9. Right, 4-2, calculate the coordinates of A. Alright, so let's have a look at the coordinates of A. So A, as you can see, A and B are the x-intercepts. Now in order to work out the x-intercepts, you make y equal to 0. We've got x minus 4 squared minus 9. Okay, you've got numerous ways of tackle this question. Well, there's two that I can think of. You can either multiply this out, or you can bring this across and take the square root. So I think that's the quickest way. So bring this across, which is 9, x minus 4 squared. You take the square root, so that would be plus minus 3 plus x minus 4. So the two answers are 3 equals x minus 4, or minus 3 equals x minus 4. Take that over, that's 7, or take that over, which is 1. As you can see, 7 is further away from the origin than 1, so B would obviously be 7 and 0, and A would be 1 and 0. So this one is not applicable, so we're interested in this one. So A is 1 and 0. Right, 4.3. If M is the reflection of C in the axis of symmetry of F, write down the coordinates of M. Alright, so let's look at the coordinates of C. Right, so C is the y-intercept. So that's what we got to figure out. C is the y-intercept. Okay, so let's do that first. So obviously the x value is got to be 0. Right, so we got y equals x minus 4 squared minus 9. So in order to work out the y-intercept, x has got to be 0. So 0 minus 4 squared minus 9. So that would be 16 minus 9. So that would be 7. So the y-intercept is 7. Right. So now C, 0 and 7, and E, which is 4 and negative 9, and M, the point that they are referring to now, will be x and 7, right? Because I said that C and M are mirror images across the point E, right? So basically all we want to do is work out this. So it's like the midpoint formula that I showed you earlier. So it's got to be x plus 0 divided by 2 should equal 4. So x should be equal 8. So the coordinates of M are 8 and 7. Alright. So when 2 points are symmetrical about the axis of symmetry, the y values would be exactly the same. Right, 4.4 says determine the equation of G in the form y equals mx plus c. Alright, so 4.4. Okay, so we need the equation, which is y equals mx plus c. Do we have the y-intercept? Yes, we do, which is 0 and 7. So that would become y equals mx plus 7. So the only other point that we have on the graph is point D. As you can see that D, this line here, is the vertical line which is parallel to the y-axis. That means that all these x values will be the same. So that x value is 4, so that means the x coordinate at D will also be 4. So that would be 4 and 0. So therefore that's 0. That's m times 4 plus c. So c is 7. So that minus 7 equals 4m. Therefore m equals minus 7 over 4. So the equation then becomes minus 7 over 4x plus 7. Right, determine the equation of G inverse. Okay, so in order to work out the inverse of a function, swap x and y, so interchange x and y, so that's x, right, minus 7 over 4y plus 7. I'm just going to times by 4, so that would be 4x equals minus 7y plus 28, right, take this across, bring that across, so that would be 7y equals minus 4x plus 28, divide by 7, so y equals minus 4 over 7x plus 4, and that is the inverse of G. 28 divided by 7 is 4, yeah, 100%. 4.6, for which values of x is x times fx less than or equal to 0. Okay, let's have a look at that. So that's where the one is positive and the other one is negative, or where the one is negative and the other one is positive. Right. Okay, so let's do that. Let's just find our piece of paper quickly. So let's have a look at where x is positive. So that's on the right hand side of this piece of paper. Everywhere that's where x is positive. So we've got to look at where x is positive and the y values are negative. So that will happen anywhere from there to there. So between A and B. So between 1 and 7. So between 1 and 7. Okay. Now we've got to look at where x is negative. Okay, we've got to look at where x is negative. So x is negative on this side, and the y values is positive. Right, so we're looking at the parabola. So the y values are positive. Yes, they are positive, which means they are above. So that would happen from 0 to negative infinity. So all x is smaller than or equal to 0. Right, that wraps up that example. So I'm just going to proceed to the next one. Right, once again, this is one of our last ones where we have a parabola and a straight line. So hopefully grade 12s, you can see that it's repetitive. The questions are repetitive. It's the same questions over and over again. Alright, so hopefully you guys are following along and you can see it's the same things that I'm doing over and over again. Alright, so the last question that we have with deals with parabolas and straight lines is x squared minus 2x minus 3, and the other one is a straight line which is gx equals x minus 3. Alright, so the question is calculate the coordinates of C. Right, now if we look at the coordinates of C, which is the y-intercept of the parabola, and it's also the y-intercept of the straight line. So clearly you can see it's minus 3. So 5, 1, 1. So the coordinates of C are 0 and minus 3. 5, 1, 2. Calculate the length of AB. So to work out the length of AB, we need to work out the x-intercepts. So how do you work out the x-intercepts? Well, make y equal to 0. So 0 is equal to x squared minus 2x minus 3. Factorize that. So that's going to be a minus, and that's going to be a plus. So x equals 3, or x equals minus 1. So therefore the length would be 4 units. Okay, so the coordinates of A are minus 1 and 0, and 3 and 0. So that means it's 1 unit from there to there, and it's 3 units from there to there. So the total is 4 units. Calculate the coordinates of D. So to work out the coordinates of D, which is the turning point, so at the turning point, the derivative is equal to 0. So let's derive it. So that's going to be 2x minus 2. So at the turning point, the derivative is equal to 0. That's 2 equals 2x, x equals 1. Substitute 1 into the original equation. So f of 1, which is 1 squared minus 2 times 1 minus 3. That will be minus 4. So the coordinates of D are 1 and minus 4. Right, calculate the average gradient between C and D. Okay, so the average gradient, so let's see, C was 0 and minus 3, and D is 1 and negative 4. So the gradient between C and D, which is minus 4 minus minus 3 over 1 minus 0, that will be minus 4 plus 3 over 1. The answer is negative 1. So the average gradient is the gradient between 2 points. Right, calculate the size of OCB. So 515. So OCB. Right. So basically they want the size of this angle. Right. Now C was 0 and minus 3. So that means that this is 3 units and this is 3 units. So if they are both 3 units, which means they are equal, then that angle there is obviously 90. So then this has got to be 45 and 45. Right, so that's got to be 45. That would be sides, angles, opposite, equal sides. Five 1 6. Let's see how we're doing for time here. Alright, 516. Determine the values of k for which fx equals k have two unequal positive real roots. Okay, now if you have two positive unequal real roots, they got to be positive, right? Now if I just take my ruler here, so if I move my ruler from the bottom up, so here my ruler is not cutting the parabola, which means we have non-real roots. Okay, so at D we have real roots, right? Equal roots and real, obviously. So if I continue moving my ruler up, we can see we have two positive real roots. The roots are the x values. So that x value and that x value is positive. Now if I continue doing that until C, okay? Now if I move my ruler up, these x values are all negative. However, where these x values are still positive. So I can't move my ruler beyond point C, because from C upwards, the one x value is negative and the other x value is positive. So it's got to be between C and D. So I think D was 1 and -4. So therefore the value of K, so you look at the Y values, because remember fx is Y, so where Y equals K, so the Y value there is -4 and the Y value there is -3. So therefore K must be between -4 and -3. Right, 517. Right, 517 is your more higher order question of interpretation. So we got the derivative times what's that? The point of inflection is greater than 0, which means where both are positive or where both are negative. Right. So let's see what the point of inflection will be. Okay. So let's see what the first derivative is. So the first derivative is 2x minus 2. So the point of inflection is 2. So the second derivative is 2. So that means that that is always greater than 0. So we can't have option 2. We can only have option 1, because this point of inflection is always greater than 0. So now we've got to look at where the derivative is positive, and obviously we know that that is positive, right? So let's see where the graph is increasing. So remember, we're looking at f, right? So here we can see that the graph is decreasing, then it is stationary, and then it is increasing. So where's the graph increasing? So the graph is increasing from 1 to infinity. So x must be greater than 1. 5.2. The graph of the parabola f has x-intercepts at 1 and 5. Gx equals 4, so that means y equals 4, is a tangent to f at P, the turning point of f. Sketch the graph of f, clearly showing the intercept with the axis and the coordinates of the turning point. Right. Okay, so let's have a look. Right, so that's 1 and that's 5. So 1 plus 5 is 6, divided by 2 is 3. Now y equals 4 is somewhere up here. So that's 6 divided by 2, which is 3, and that is a tangent. So therefore the graph will look like that. Okay, I missed both x-intercepts, but anyway, you get the idea. That should be 5 and that should be 1. So that coordinate there is 3 and 4. And that is the equation of f. There we go. Right, so let's just recap quickly there. Those are the two x-intercepts. The turning point lies between the two x-intercepts. 1 plus 5 is 6, divided by 2 is 3. And y equals 4 is a tangent. So that means the y value there must definitely be 4. Right, so in the next video we're going to look at some log and exponential functions and the inverse of a parabola, log and exponential, and log and exponential. Right, so stay tuned for that.